Hello guys, welcome to Deep Codes, and in today's video we will discuss LeetCode question 516 that says longest palindromic subsequence. So guys, this is very interesting question, and this question will help you understand the concept of recursion as well as memorization, and this is very much foundation question to understand dynamic programming. So yeah guys, stick till the end and make sure you like this video. Now here you are given a string S and you need to find longest palindromic subsequence length in S. So now the first question arises, what is subsequence? See, a subsequence is a sequence of characters you can form by deleting some of the characters. So if you have something like this, let's say B, B, A, C, A, B. So what is one subsequence you can form like B, B, A, B? This is valid subsequence. B, B, C, this is valid sequence. Then B, B, C, A, this is valid sequence. This all are valid. But you can't form like B, B, AC. This is not. So you cannot change the order of the characters. You can only delete some of the characters from the given string. This is the given string, and these are not valid subsequence where you deleted some of the characters, but you cannot change the order. Clear what is subsequence? So we need to return longest subsequence for a given input string. Now here, and that longest subsequence must be palindrome. Yeah, keep this in mind, palindrome. So in this first example, this BBAB, BBAB. So BBAB. So here, if you delete this character A, then you will get something like BBBB, and this is palindrome, right? If you read from the front as well as read from the back, both the time the string is the same, correct? So yeah, this is the longest palindromic subsequence that can be formed. See, another subsequence you can form is like this, something like this, BAB. This is also valid palindromic subsequence, but this length of this subsequence is 3, whereas this is 4, and we took the longest. So yeah, this is our answer. Okay, clear? Now if you take a look at the second example, here to form a valid subsequence, the only subsequence that is palindromic, it is BB. So yeah, its length is 2. So apart from this, you can also take like C, character C itself, character D itself, character B itself, but all these are palindromic but of a length 1. So that's why they are we didn't consider this as our answer. This is the longest, so we written 2 as our answer considering BB. So yeah guys, I hope the question is understood now. Now for any given string, let's say if you are given a string something like this. So guys, for any given string like this, what you have some choices, right? Choices of characters. Choices of characters. To choose the character from which you can form palindromic subsequence. Okay, so whenever you have choices of something, then based on the choices, what you can form? You can form a choice diagram or this recursion tree. How you will form that? Let us discuss that. So at the root, what we have this complete string, and each time we start off with an index. So index 0. So for each character we have only 2 choices, right? Include and not to include. So if you include it, now the current subsequence has B. If you don't include, then it is empty, correct? Now you check for another B. So for that also you have 2 choices, include, not to include. So in that way, if you include it, then you can get BB, and if you don't include it, you will only get B. And similarly here also you have 2 choices for this answer, that is include, then you will have B, and not to include, then it will be empty string. The next character comes A. Okay, so from here also you have 2 choices for A. Each node, from each node of this string you have 2 choices for A, include, not to include. Same thing at every places. So like B, B, A, then B, 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 A, only B, B, A, only B, A, and empty string. So guys, clear till here? Now for the next character B, we have again choices, right? B, B, either to include, not to include. So if you will include it, it will be B, B, A, B. So yeah, you have this type of choices everywhere, and this is how you form recursion tree. Okay, got this? So at this point, after moving down forming this recursion tree, at some point you will get some answers, like you will also get this answer BBA, BB, BBA, BB, right? And this is the valid answer. So after forming this, after coming towards the end, when our index is reached here, that there is nothing in the string. So after, at that point, we will check if it is a palindrome or not. Okay, we will check if a string is palindromic or not. And if it is a palindromic, then what we will do, we will return its length. Simple it is. First, for each character we have two choices, so we maintain two choices. Then after we reach towards the end of the string like this, when there are no more characters remaining, at that point we check if the string is palindrome or not. And if it is palindrome, we return the length of the string. If it is not, if it is not, then return 0, right? So yeah, this is the recursive approach that we will use to solve this question. So if you have any doubt of how this recursion tree will form, try to make this tree by yourself. Try to complete this tree until you reach the end. See, every time we are taking the new index, new character, so this tree will form until no more characters are remaining. And for each character we have two choices, either to take or not to take this character. Okay, we have two choices only. So now guys, based on this recursive approach, we will code our recursive solution. It would be the same. The code for the recursive solution would be directly the copy of the approach that we discussed. So here in the code, what we did, we call this one solve function, where I pass the given string, the new subsequence, and the index 0. Okay, we are starting with the index 0, and this s1 will store the current subsequence. Okay, so this is the base condition. Let's discuss this afterwards. So as I told you that there are two choices, and both choices will return some answer 1 or answer 2. So one choice is to include the current character that is at present at the index in the current sequence, and another choice is not to include and not to include. So yeah, if you include it, then add the current character in the current subsequence and move ahead. If you don't include, then simply don't add and move ahead. So yeah, this both choices will result into some answer, and that's why we store in answer 1 and answer 2, and at the end we return the maximum of both the answers. Okay, so if you reach towards the end where index is greater than equal to size of the main string, then at that point we check if the subsequence or the current subsequence s1, if it is palindrome or not. Yeah, right. So that's what we discussed. After we reach the end when no more characters are remaining, at that point we will check whether the current subsequence is palindrome or not. If it is palindrome, return its size, else return 0. So for this palindrome check, we are simply checking the first and last character, and we are incrementing and decrementing the pointers, the starting pointer and the ending pointer. This is the simple palindromic code. So guys, I hope you understood this recursive approach. Now talking about the time complexity of this recursive approach, so it will be power of 2 to the power of n, where n is the size of this string, correct? Thus this would be the time complexity. Okay, so we can further reduce this time complexity to big O of n square, right? We can reduce this time complexity to big O of n square by using what? By writing better code from recursion and solving it and decrementing the time complexity to big O of n square by using memoization. Let's discuss this approach now. So guys, if you look at here, for a subsequence that we are forming, and at the end we are checking for palindrome. See, what we are doing, forming a subsequence and checking whether it is palindromic or not, is palindrome or not, whether the subsequence that we have formed s1 it is palindromic or not. So can we do this? Can we do both the step in one? See, can we form a subsequence and check if it is palindrome or not? Can we do both this thing in one function? Can we do that? Yeah, we have to think of this. If we can do this, then this entire time complexity will be reduced. See, here it would be 2 to the power n plus some big O of n complexity will also be added, because each time we are checking whether if the subsequence is palindrome or not, correct? So for each subsequence generated, so it will be multiplied. So this time complexity will be multiplied with big O of n. For each subsequence generated, this many subsequences are there, and for each subsequence we are checking if it is palindrome or not. So now guys, can we both do this in one thing? So what if we add, whenever we are adding this character, say we are including this characters, we check for palindrome. So on include step, check for palindrome. Okay, that thing only we have to do, because whenever we are including a character, then at that point only we can check whether the character that we are including can result into palindrome substring or not, subsequence or not. If the character that we are adding, if that doesn't result in a palindrome subsequence, then we can discard it. Correct? Clear till here? Now, what another thing that help us to satisfy whether the string is palindrome or not, means how to check if it's palindrome. Check for palindrome. How we can check whether the given string is palindrome or not? We match the ith pointer and the jth pointer, right? See, for a given string like this, b, a, b, initially the I pointer is here, j pointer is here, both matches. Then increment the I and decrement the j, both matches. Then increment I and decrement j, both matches. So this is how we keep two pointers, one pointer at the beginning and another pointer at the end, and we match. For if both the characters match, then we move ahead by incrementing the I and decrementing the j. Okay, so this can we include this condition of I and j pointer in our main solve function. So yeah, that only we will do that in the memoization approach. We will memorize it, as well as we will keep an eye whether including this character will form a palindromic subsequence or not, and based on that we will do some calculation. Okay, so guys, here what we are doing, here we were storing this subsequence as in a s1 string, and we were taking index parameter here. So instead of that, what we will do here is we will take two parameters integer, that is I and j, and this I and j would be nothing but this to check whether the including the ith character and jth character will result in a palindrome or not, palindrome subsequence. So for that only we are including I and j, and we have removed this subsequence s1. This we won't store s1 string. Instead, we would only keep a track of whether taking the ith character and jth character would result in a palindrome subsequence. If they both are same, then yeah, that would result in a palindrome subsequence. So we will include them. Okay, so first take a look at this step. This is include step, and this is not include. Okay, so in the include step, what guys, what we are doing is just focus here. See, we are if the character at I position is equal to character at j position, that means by including this character I and j, we can form a palindrome subsequence. And that's why, since we are including two characters at a time, we are incrementing by 2. We are adding 2 to our answer, right? At the end, we are not returning size of a subsequence, because here we are not storing subsequence. Instead, we are storing the length of a subsequence during the calculation. So if we find some characters I and j that both are equal, then yeah, we can include those characters. And if you include those characters, our length of subsequence will increase by 2. So yeah, we return 2 as our answer, and we further incremented our I and decremented the j. That's how we do in palindrome check. This is what we do. We increment I and decrement j. Correct? And if we don't include, then what we would do, we would simply take maximum, either to increment I or to decrement j. We have two choices, right? If we don't want to include, then we have two choices, and at that point we would return the maximum of both of them. Simple it is. So this include and not include condition would remain the same. Okay, now instead of storing the subsequence, what if we can store the length of each I and j, each possible for each combination of I and j, we can store the answer. So for that we took this dp2d array. So since if we look at the constraints here, the constraints are of 1000. So we took a dp of 1001 and 1001 to store different values of this I and j. To store different values of this I and j, we initialize this dp with -1, and then we check if the dp of ij is not equal to -1. That means we have computed the answer somewhere in the past. So if you have computed the answer somewhere in the past, we will use it. See, here by using dp, we solved problem of repeated subtrees. That means, let's say, let me show you. So this was our recursion tree. So if you take a look, if you take a look over here, see, this will form one subtree. From this b, we have two options, either to include and not to include. From here also, from this b, we have two options, either to include and not to include, and both are at same level. So these are what? Duplicate subtree. You can tell this as duplicate subtree. And also see, so all the calculation that you will do here, the same calculation you will do here. See, both are same level and both are same. See, both subtrees are same. So if you do a recursive solution, then you calculate for the same subtree multiple times due to presence of this duplicate subtree. So to reduce that calculation, what we check, that we check if the answer is already there in this DP or not. If the answer is there, then it won't be -1, it would be 0 or any values greater than 0. So in that case, we simply return DP of ij to solve this problem of repeated subtree. So yeah, guys, clear till here. And these two basic conditions, if I is greater than j, that means we have reached at some point where I is here and j is here, right? I is towards the right of the j, then at that point we return 0, right? And if I equals to j, so at this middle place where I and j is same, then at that point we return 1, correct? Then we can take that character in our subsequence. So yeah, we return 1. So these two condition, these two are the terminating condition. This condition we discuss, and these two are the choices, and at the end we return dp of I and j. Okay. So yeah, that's all for this memorization approach. And this I, we initialize I to 0 and j to the last character. That's what we do in the palindrome check. So here in this memorization approach, we added the palindrome check, as well as we reduce this recursion problems like duplicate subtrees by using memorization DP here. So yeah, guys, that was our memorization approach. And now talking about the time and space complexity of these approaches. So the time complexity here is big O of n square. I will explain you. And the space complexity is also big O of n square. See, the space complexity, you can see here that we are using 2D DP, and that's why our space complexity is n square. Now this solve function, what we are doing in the solve function, we are simply storing different values of I and j in this DP. So to store all the values of this DP, what time we will require? We will require n square. Means to store n square boxes of this DP, or n square cells, you can say, of this DP array. How much time we would require? We will require big O of n square. Okay, clear till here? So yeah, that's why our time complexity is big O of n square. And yeah, this solve function, our space complexity would be added of due to this recursion we are using. So plus recursive stack for the space complexity. So yeah, guys, that's for the complexity part. And yeah, that's all for this video. If you guys have understood what is the recursive tree, what is the recursion, how to code for the recursive solution, and based on the recursive solution, how we coded for the memorization. So I hope you guys have understood all these different things that we have discussed here. If you guys have still any doubts, then do let me know in the comment section. Make sure you like this video and subscribe to our channel. Thank you.